Good morning, students. Once again, I welcome you to my video lectures on control systems. I was going through the guidelines. After angle of departure, then centroid calculation. After centroid calculation, breakaway point calculation, break-in point calculation. The next guideline is what is known as intersection of j omega axis. So for a student who is going to plot a root locus, the student has to know whether the root locus he or she plotting going to cross j omega axis, either from left of plane to right of plane or from right of plane to left of plane. And the crossing point, at the crossing point, the value of k is very crucial because that is going to decide stability of control system. So marginal value. Now the next guideline is j omega axis crossing. So how to find j omega axis crossing is a question. In most of the textbooks, they follow Root-locus criterion. So you know, before going to take up root locus, you have gone through what is known as Root-locus criterion. Most of the textbooks uses Root-locus criterion, but I will follow this method. I think this method is easy for you. The points j omega axis cross section. I think it is guide number 7. It is guide number 7. J omega axis intersection. The points at which loci cross the imaginary axis and the value of k at crossing can be obtained from characteristic equation by letting s equal to j omega. I will explain this. Now first as an example I will take an example. GSHS equals k over s into s plus 6. You are familiar with the root locus of this problem. This is the problem. Pole at s equal to 0, pole at s equal to minus 6, and this is the root locus. This is the root locus. Here there is one and only crossing point. So that is at s equal to 0. You can find that. Form the system characteristic equation. We have to form system characteristic equation. How to form system characteristic equation? 1 plus GSHS equal to 0. Therefore, 1 plus k by s into s plus 6 equal to 0. Therefore, s into s plus 6 plus k equal to 0. So, this is j omega axis. This is j omega axis. This is real axis. This is j omega axis. On this j omega axis, s equal to j omega. So substitute s equal to j omega here. Substituting s equal to j omega here, we get substituting s equal to j omega here, we get j omega into j omega plus 6 plus k equal to 0. Next, separate real parts and imaginary parts. Now multiply j squared omega square plus j6 omega plus k equal to 0. J squared is minus 1. Therefore minus omega square plus j6 omega plus k equal to 0. Now separate real parts and imaginary parts. K minus omega squared plus j6 omega equal to, now I will write 0 as 0 plus j0. 0 plus j0. Now after separating the real part and imaginary part, so real part is equated to 0, imaginary part is also equated to 0. So first equate imaginary part. What is imaginary part? 6 omega equal to 0. Therefore, what is omega? Omega equal to 0. And Take real part, k minus omega square equal to 0. Substitute that value of omega. So omega equal to 0 means k minus 0 equal to 0. Therefore, at k equal to 0 and omega equal to 0, there is a crossing point. So that is why here crossing point. So this is the crossing point. This is entering. So the root locus is entirely in the left half plane. Starting point is only it is intersecting j omega axis. So omega equal to 0 here k equal to 0, omega is also equal to 0. This is what is called as j omega crossing point. Now I will take the next example. Now next example, GSHS equals k over s into s plus 1 into s plus 2. So we are already familiar with the root locus of this example. The root locus of this example is pole s equal to 0, pole s equal to minus 1, pole at s equal to minus 2. And this is the root locus. This is the root locus. Now there is a crossing point. Now here at these 2 points, the root loci crossing j omega axis from left half plane to right half plane. So we can find the intersecting points. First, form the characteristic equation. The characteristic equation is 1 over k over s into s plus 1 into s plus 2 equal to 0, or s into s plus 1 into s plus 2 plus k equal to 0. Next, simplify. Further simplifying, s into s square plus s plus 2s plus 2 plus k equal to 0. Then simplifying s into s square plus 3s plus 2 plus k equal to 0, s cube plus 3s square plus 2s plus k equal to 0. Then substitute s equal to j omega. J cube omega cube plus 3j omega square plus 2j omega plus k equal to 0. J cube means j squared into j. J squared is minus 1. Therefore, minus j omega cube. And here j squared. J squared means minus 1 minus 3 omega square plus j 2 omega plus k equal to 0. Now separate real parts and imaginary parts. K minus 3 omega square plus j 2 omega minus omega cube equal to 0 plus j0. 0 plus j0. Next is equate after separating real parts and imaginary parts. Now equate real part and imaginary part to 0. Equating real part and imaginary part to 0. First equate imaginary part to 0. 2 omega minus omega cube. 2 omega minus omega cube equal to 0, or omega into 2 minus omega square equal to 0. Therefore, omega equal to 0 is one crossing point, and 2 minus omega square equal to 0, or omega squared equal to 2, and omega is equal to plus or minus root 2. So next, substitute here. K minus 3 omega square equal to 0. First substitute k equal to 0. So substitute omega equal to 0. We get, for omega equal to 0, we are getting k equal to 0. Next, substitute omega square equal to 2. Substituting omega square equal to 2, we get k equal to 6. Therefore, we are getting 2 points. Omega equal to 0, k equal to 0, 1 point. And omega is equal to plus or minus root 2 and k value is 6. Now, these are the intersecting points. This is one intersecting point. Omega equal to 0, k equal to 0. Next, omega equal to plus root 2. Omega equal to plus root 2. Root 2 means 1.414. And the omega value is at 1.414. That is at j 1.414. It is going to cross into right half plane, and k value is 6. K value is 6. This is one point. Another point is omega equal to minus root 2 and k value equal to 6. So this is how we have to find. This is how we have to find the intersection of j omega axis. Sometimes the j omega axis may be crossed like this. It can cross more than once. So chances are also there. So more than once it can cross. I will come to those examples later. So starting, I am going through guidelines. Therefore, you are very much to be thorough with this rule, that is j omega axis intersection. So form characteristic equation, substitute s equal to j omega, then separate real part and imaginary part. So equate real part as well as imaginary part to 0 and find the omega value as well as k value, that is marginal value. Thank you.